Okay, today we're doing, well, today I'm doing 1-2. I don't know when you're doing 1-2. Anyways, this is what this video's over. As you can see, it starts on page 17. Couple definitions you probably should write down in case they appear on a quiz or a test. The first one is equation. It's a mathematical statement that two expressions are equal. An equation has an equal sign, an expression does not have an equal sign. That's one way you can tell. An equation is made up of two expressions. The solution of an equation is the value of the variable that makes the equation true. Right now, we're only going to have one true value that will change as the year goes on. You know about inverse operations, or you should by the time you're in Algebra 1. The opposite is basically what it means to undo something, okay? So the opposite of addition is subtraction. The opposite of subtraction is addition. So if I tell you to use the inverse operation, it means to use the opposite, and it undoes an operation. We'll talk more about that tomorrow, I think, when we do multiplication and division with equations. This should be pretty much a review for most of you, I would hope. If you're in Algebra 1, it should be a review. But with equations, since they're two equal expressions, we like to keep them balanced, which means if we do one thing to the right side, we have to do the same thing to the left side. So if we subtract 4 from the right side, we must subtract 4. That should say from the left side, right there. There, I fixed it. So if we subtract 4 from the right side, we must subtract 4 from the left side. Just like if we added 4 to the right side, we have to add 4 to the left side. So we're going to do some problems now. We're going to look first at example number 1. There are a few problems to look at. The first one says the following: x minus 10 equals 4. So let's write that out. So we got example 1 here. So, x minus 10 equals 4. The goal, you should probably write this down. The goal is to get the variable, to isolate the variable. I'm going to use mathy words with you guys. I will explain what the mathy words mean, but I'm going to use them. Isolate the variable means to get it by itself. If you are isolated on an island, it means you are all by yourself and nothing probably good is going to happen. Anyway, to isolate the variable, these are called one-step equations because there is one step to it. If you look on the left side, you have x minus 10. We want to get this guy, or the variable, all by itself. So we have to look to the other term in the expression, which is negative 10. If I want to move negative 10 to the other side, to get it away from the x, I have to do the inverse operation, or the opposite of what is being done right now. So if 10 is being subtracted right now, the inverse of that is addition, because addition is the opposite of subtraction. So I'm going to do the inverse and add 10 to the left side. Now if I add 10 to the left side, I have to add 10 to the right side. These will cancel because they're opposites. Anytime you have a negative 10 and a positive 10, anytime you have two numbers, one of them that are the same, one is negative, one is positive, they equal 0. So I can just put an x through them, which leaves me with just x, and 4 plus 10 is 14. Okay? Now if I were to check that problem, I can show you that this is right. By evaluating, we talked about that yesterday. So if I have x minus 10 equals 4, and I'm checking, really I'm evaluating, I know that x equals 14. So in for x, I put 14, I put it in parentheses because I like parentheses, and I subtract 10, and I get 4. 14 minus 10 is 4, and 4 in fact equals 4, so you got the right answer. If 4 didn't equal 4 right now, that would mean this here is incorrect and you need to start over. Okay, so the next problem is example 1, letter B from page 17. Now on A, the variable was on the left side. This one, the variable is on the right side. So we're going to look at this side first because that's where the variable is. Okay, the goal is to get this M all by itself. So we have to move what isn't with M to the other side. -1/5 is not with M. So this is what we are moving. You don't have to draw these little boxes. I'm just using different colors to show you what I'm talking about. So that is a -1/5. So we need to use the inverse operation to undo it. Inverse of subtraction is addition. And you got lucky with these ones because they have common denominators. So you don't have to do any way extra work. So if I have -1/5 and I add 1/5 to the right side, I need to add 1/5 to the left side. These cancel because they're the same exact number, one with a negative, one with a positive. So now I'm just looking at the left side. Since they have common denominators, I just add the numerators, 2 plus 1, and get 3. Leave the denominator alone, and that equals M. If you wanted to check and see if that was right, you would put the 3/5 in for M, and you would subtract 1/5 from it, and hopefully you can do that in your head. 3/5 minus 1/5, I'm just going to show you right here. So minus 1/5 is 2/5, and since this 2/5 equals this 2/5, you know you got the right answer. Okay, so we have flipped the page. We are on page 18 now. Example 2, letter A. It says x plus 7 equals 9. So the first thing, we look to the side with the variable. We have to get that to where it's just a variable. So I have to look at what isn't the variable. This is what isn't the variable. I have to move that to the right side to get the x all by itself. So right now that's positive 7. And we know that the inverse operation, or what undoes addition, is subtraction. So we're going to subtract 7 from both sides. Since these 7s, one's positive, one's negative, they cancel out, which leaves us just with x on the left side. 9 minus 7 is 2. If I wanted to check that, I would put this 2 in for x. So now we have a 2 right here. 2 plus 7 equals 9, you know you got the right answer. Eventually you're going to have to check those, as in where you're writing x plus 7 equals 9 and then substituting, but there's a reason for that. Right now, these are simple enough problems where you can just take your answer and just plug it back in like I just did and not work it out. Okay, so just like the last two we did, this time your variable is on the right side. Okay, what is not the variable, or what is the point 4? That's what we need to move to the other side to get the variable by itself. It's being added. We know the opposite of addition is subtraction, and we subtract that number. If I subtract 0.4 from this side, I need to subtract 0.4 from this side. There should be a 0 right there. Because these are the same numbers, but with opposite signs, they cancel. I look to the left side. 0.7 minus 0.4 is 0.3, and that equals R. Okay, this is my answer. I can take this, put it in for R, so this is 0.3, and I know that 0.3 plus 0.4 equals 0.7, and I know I got it right. Okay, this problem is a little bit different, but not really. The only thing is it's set up as -8 plus b instead of b minus 8. So your negative is at the beginning. Okay, so this is the side with the variable. And we know that this is the part with the variable that we need to move to the other side. That is a -8. The opposite of -8 is +8 to undo subtraction. Negative sign and subtraction sign mean the same thing. So to undo subtraction or negative, you do positive. So this is +8. And if we do that to the left side, we got to do it to the right side. These cancel, and we end up with b equals 10. Okay? If I put this 10 in for that, -8 plus 10 does equal 2, because 10 minus 8 equals 2. Hopefully you remember your integer rules. But if you need a number line or anything, come talk to me. I have number lines. They're pretty cool. Okay, so example 4 on page 19. A person's maximum heart rate is the highest rate in beats per minute that a person's heart should reach. One method to estimate the maximum heart rate states that your age added to your maximum heart rate is 220. Using this method, write and solve an equation to find the maximum heart rate of a 15-year-old. Whenever you're doing story problems, there's stuff in there that's not important. And this right here is not important. Okay, so I would suggest if you're doing a test or something, you go through and you cross out what's not important. Then it says using this method, write and solve an equation. Well, that helps us not a bit, except the fact that we're supposed to find the maximum heart rate of a 15-year-old. Okay, so that's why I wrote out down here, age added to your maximum heart rate is 220, because I got that from here. And this is in my sentence that is not crossed out, so I know there's important information right there. Okay, we can cross that out. So your age added to your maximum heart rate is 220. Well, the problem tells us right here that our age is 15. So we can say, okay, the age is 15 added to, we know that's added. We don't know your maximum heart rate, okay? Don't know it. So we're going to say that's R for rate. Is, you should know that is means equals 220, okay? So then we have our variable on this side. This is the part that we need to move. It is positive 15. So we do the opposite, just like so. These cancel, and you get R equals 205. Okay? That means your maximum heart rate for a 15-year-old should be 205. Now, if you put that 205 right there and add 15 to it, you get 220. So we did it right. That means you can put any age. If your mom or dad's 35, you could put 35 in for 15 and you could tell them what their maximum heart rate should be and they'll think you're super smart. So, anyways, that is the lesson. Your assignment is pages 20 to 21. And we got numbers 17 through 31 on. And we have some story problems for you because, you know, I like to make your life difficult. 37 through 47 on. Remember, if you are watching this at home, you save those and do those tomorrow. You can watch the next part if you are having trouble figuring out how I want you to set your paper up. Most of you probably already know how to set your paper up in an organized way that works for you because you had Mr. Pogue last year. However, if you're a little like, I don't know how I should set my paper up, you don't really need your name on your paper because it should be in your notebook, okay? Make sure those holes are on the left side, okay? Maybe write the assignment number up here, or not the number, but the assignment, what it was, okay? 1-2, 17 through 31 odd, and 37 through 47 on. I should have done this on yesterday's, but that's okay. Okay? And then start with number 1 here. Show all your work, so if it's like x plus 2 equals 5, you would write x plus 2 equals 5 for the problem down. You would show minus 2, and x equals 3. Okay? I don't just go through this stuff to and show you the minus 2 because I need to remember that I'm supposed to do that to both sides. So make sure you show all your work. Do not just put 3. If you just put 3, I will make you redo it. And then, obviously, so this was 17, then do 19 here. Maybe skip a line between your x equals 3 and where you put 19. Once you get to the end of that column, come up, say you got through 31 on that column because they're short, put 37 up here, make it 2 columns. You can, what I've always told my kids before is to just fold their paper in half and they have a nice crease here, or if you don't need that crease because you're just a person who can make your papers nice. So put 37, work it out, and then put 39. Make sure you circle your answers, that will be helpful. So, if you watch this part, And you can tell me, put on your paper the word lucky star. Okay, so you watch this whole video and you write lucky star at the top of your paper. Just, right by the assignment, write lucky star. I will give you not 2 points, but 2.5. And that will be some extra credit. Now you're like, half a point. That's actually 25% extra credit on that assignment for writing lucky star at the top of your paper. So, go enjoy your evening. And if someone beside you does not have the word lucky star beside it, do not tell them about lucky star, okay? Hopefully you can not tell them.